In our last video, we looked at using the addition property to solve equations. Now, we're going to look at what's called the multiplication property to help solve equations. Once again, if you have an equation that says the left side is equal to the right side, you can multiply both sides of the equation by any number and you will get an equivalent equation. If you have A equals B or a left side equals a right side, you can divide both sides of the equation. So you would be safe in saying you can virtually do anything you want to an equation as long as what you do to the left side is the same as what you do to the right side. There are a few little restrictions, but we don't need to really worry about those right now. In these problems, we're going to see what does an equation look like that needs the multiplication equality. You can see in this equation, let me write it down. I have 4x equals 60. There's my barrier. Now, the x is over here on the left-hand side, and it is not alone like I would like it. But what's going on? That 4 is not being added to x. It is not being subtracted to x. It is being multiplied times x. And what is the inverse of multiplication? Well, the inverse of multiplication is division. So I will take 4x and I will divide it by this number 4. But if I do that to the left-hand side, then I'm going to have to take the right-hand side and divide it by 4. Okay, I'm doing the inverse of multiplication is division. Well, what is 4 over 4? That's 1x is equal to, and 60 divided by 4 turns out to be 15. I don't need to write that 1. X is 15. You could check it. Is 4 times 15, which is the value you got for x, equal to 60? And the answer is yes, it is. So it checks. Something checks if it makes the statement true. Let's look at number 2. It has negative 7. Ooh, come back here. It has negative 7z is equal to 49. There's my barrier. There's the z. I want the z by itself. Well, what's going on with the negative 7 and the z? Even though it's negative, it's not being subtracted from z. It's not being added to z. Because it's sitting adjacent to the z, right next to it, that's implied multiplication. What's the inverse of multiplication? Division. So I will take negative 7z and I will divide it by negative 7. Don't change the sign. Keep the sign identical. Equals 49, and you'll need to do the same thing, divided by negative 7. Negative 7 divided by negative 7 is implied 1. Z is equal to, now use your division rules. The division rules say if the signs are alike, you get a positive. If the signs are different, you get a negative. So I get negative 7. Z is negative 7. Let's look at number 3. I have 12z is equal to negative 36. I look at this equation. I want z by itself. There is a number times z. I'm going to save a step in this problem. And I know that that's 12 times z. I'm going to divide by 12, and I'm going to just write it right now. I have to do it to the left side and to the right side. 12 divided by 12 is 1z is equal to, division rules, negative 36 divided by 12 gives me negative 3. Z is negative 3. Number 5. Did I skip one? Yes, I did. Sorry. Number 4. Negative 5x is equal to 0. I look at this. I want to solve the equation for x. Here's the term that has the x. There's a -5. It's implied to be times. That means I have to do the inverse, which is divide. Divide by -5, divide by -5. When you use division, make sure that these two numbers are identical so that you get 1x is equal to, and 0 divided by anything is 0. X is 0. Number 5. -9x is equal to -9. I look at the equation. The unknown, the variable, the letter is right here. It's an x. What's going on with it? -9 is getting multiplied by it. So you will do the inverse of that, which is divide. You're dividing by -9, and you do it to both sides. These should always be identical and give you a 1, x. And on the right-hand side, just coincidentally, on this side, I get a 1 also. So x is 1. I could check it. -9 times the value of x, which is 1, is supposed to equal -9. And it does. All right, number 6. I have 8z is equal to -72. Okay, look at both sides. There's my z. What's going on? Multiplication. What will I do? Divide. Divide by 8 so that those will cancel. Divide by 8. That gives me implied 1z is equal to -72 divided by 8 is -9. Z is -9. All right, number 7. -14y is equal to -140. There's my barrier. Where's my variable? My unknown, my letter. Well, it's right there. What's going on? Not addition, not subtraction, multiplication. We're going to do the inverse. So I'm going to divide by -14. That will divide out. But if I do it to the left side, I have to do it to the right side. That gives me y, implied 1y, is negative divided by negative is positive, positive 10. Y is 10. Looks like I have one more. I have -80 is equal to 16y. This time my attention is on the right-hand side because that's where my letter, my variable, my unknown is. What's going on? Not addition, not subtraction, multiplication. To undo the multiplication, I will divide that by 16. But if I did it to the right-hand side, I have to do it to the left-hand side. And that gives me -5 is equal to, those divide out, implied 1y, -5 is y. All right, so that's the multiplication property, which says I can multiply or divide both sides of an equation if that will help me solve it.